Hello viewers, in today's class we are going to discuss one important integral inequality. So in this class we'll see how we can prove this important inequality, in which we have to show that the value of the integral 0 to 1 x times sine inverse x whole square dx is less than or equal to pi square over 8, right? So without actually evaluating this integral, we have to show that the value of this integral is less than or equal to pi square over 8, or in other words we can also say that the value of this integral cannot exceed over pi square over 8, right? So let us start. So let us first consider the graph of sine inverse x, right? So here we have 0, here we have pi by 2, and here we have minus pi by 2, here we have minus 1, and here we have plus 1, right? And we know that from the theory of inverse trigonometric functions, the sine inverse x, it belongs to the interval that is minus pi by 2 to pi by 2, right? So the range of sine inverse x belongs to this interval. So here if we draw the graph of sine inverse x, these are the two lines parallel to x-axis. This line is x is y is equal to minus pi by 2. This line is y is equal to pi by 2. So the graph of sine inverse x, it goes like this. Here we have the 2 points. So we can write, we can draw like this. So this point is our 1 comma pi by 2. And this point is minus 1 comma minus pi by 2, right? So the principal branch of sine inverse x lies in the closed interval minus pi by 2 to pi by 2. So now we know that when x belongs to the interval minus 1 to 1, from minus 1 to 1, then sine inverse x belongs to the interval minus pi by 2 to pi by 2, right? And here the limits of integration vary from 0 to 1. So we'll restrict ourselves to this interval, that is 0 to 1. So when x belongs to the interval 0 to 1, which is our limit, that is lower limit is 0, upper limit is 1. So when x goes from 0 to 1, then the value of sine inverse x, that is sine inverse x, it belongs to the interval 0 to pi by 2, right? So we can also write it like this: sine inverse x is less than or equal to pi by 2. So this is an important inequality to begin with, right? So we'll solve this inequality with the help of this inequality. So when x belongs to 0 to 1, then sine inverse x is less than or equal to pi by 2, right? Now what we will do, see, when sine inverse x is less than or equal to pi by 2, then the square of sine inverse x should also be equal to or less than pi square over 4. Or in other words, we can say that if we square both the sides, so we'll get sine inverse x square is less than or equal to pi square over 4. Right? Now see, here in the integrand we have a term that is x associated with sine inverse x square. Right? So what we'll do, we'll multiply this inequality with x both sides. So we have x sine inverse x square is less than or equal to pi square over 4 times x. So now integrating both sides from 0 to 1, we'll get 0 to 1 x sine inverse x square dx is less than or equal to the integral 0 to 1, and we have pi square over 4 x dx, right? So if we denote this integral by say I, then we have I less than or equal to pi square over 4 integral from 0 to 1 x dx. So we can solve it further. So we have pi square over 4. The integral of x dx is x square over 2. Limits are from 0 to 1. So we have I less than or equal to pi square over 4, and taking x is equal to 1, we have 1 square over 2, and then taking x is equal to 0, we have 0 over 2, right? So this is I less than or equal to pi square over 4 times half. This term is 0, so we have half. So this is I less than or equal to pi square over 8, right? So this is our desired inequality. So viewers, this is how we can obtain this inequality. And here I would like to mention one important result from definite integrals, right? Now see this inequality. So here we have x times sine inverse x square is less than or equal to pi square over 4 times x, right? So if we denote this function by say g of x, right? And this function by f of x, right? So we'll get g of x is less than or equal to f of x. So we can also write this inequality as fx greater than or equal to g of x, right? So whenever we have two functions f of x and g of x such that f of x is greater than or equal to g of x in some interval, say a comma b, or we can write x greater than or equal to a less than or equal to b. So whenever we have this condition, then the integral of f of x from a to b dx should be greater than the integral of g of x from a to b, right? So we have applied this property to this inequality. And moreover, these two functions f of x and g of x should be continuous functions in the given closed interval.